Hello, we are from Group 5 and this is our video about Introduction to Doppler Instrumentation. The team member consists of me, Moyongle, Shakirin and Daniel. We will be discussing about color Doppler, pulse wave Doppler and power Doppler.
Firstly, what is an ultrasound Doppler? A Doppler ultrasound is a non-invasive imaging technique that uses sound waves to produce images of blood moving through the circulatory system. Unlike the standard ultrasound, which only shows the structure of organs and vessels, Doppler ultrasound provides information about the direction and the speed of blood flow. This allows healthcare providers to evaluate the circulation of blood through the heart, arteries, and veins, helping to identify potential problems such as narrowed vessels and blockage. There are several types of Doppler ultrasounds, including color Doppler, pulse wave Doppler, and power Doppler. Doppler ultrasound is commonly used to detect narrow arteries and veins, identify blood clots, evaluate blood flow after surgery, and assess maternal fetal circulation during pregnancy, making it an essential tool in modern medical diagnostics. So now, I will talk about the color Doppler. Color Doppler uses the principle of pulse wave Doppler, but sends multiple pulses per line called the color packets. It is used to calculate the average blood velocity at different data. An autocorrelation algorithm processes this signal to show the mean velocity, flow variance, and signal strength. Color maps helps us to visualize blood flow. Red shows it flows towards the transducer, the blue color shows flows away from the transducer, and the black in the center means no flow. Brighter or more distant color indicates a higher velocity, while color near black indicates a slower flow. So in variance mode, we can also see a laminar versus turbulent flow, which helps us detect abnormal circulation. Clinically, color Doppler is often used for the carotid arteries to detect narrowing or plaque, and for abdominal vessels such as aorta or renal arteries, it is to check for blockage and abnormal flow. So, in color Doppler, not only shows us where the blood is flowing, but it also gives us important information about how fast and how smoothly it flows, making it a valuable tool in medical diagnostics.
Now I'm going to talk about how pulse wave Doppler function. Pulse wave Doppler sends short pulses of ultrasound and analyzes the reflected sound wave between pulses. It uses a single element transducer, which is the same piezoelectric crystal, to send and analyze the sound wave reflected from a specific location. There is a time delay between the transmitting pulse and detecting echo signal that correlates the distance of the reflecting object from the transducer. Sample volume is a small, defined region that the ultrasound beam focuses on to gather data about blood flow. When transducers emit sound wave, they bounce off moving blood cells within the sample volume. The same transducers then receive the reflected wave. The size of sample volume is adjustable to focus different blood vessels to make more accurate measurements. Spectral waveform is a graphical output of pulse wave Doppler showing blood flow velocity over time. It also demonstrates the direction of blood flow, whereby the waveform display above the baseline is flowing towards the transducer, while display below the baseline is flowing away. It can also demonstrate flow patterns such as laminar flow, which has a narrow spectral width and a clean spectral window, disturbed flow with spectral broadening and filling in of spectral window, and lastly, turbulent flow with spectral broadening and loss of spectral window. The downside of pulse wave Doppler is it has Nyquist limit, which is calculated as half of the pulse repetition frequency. Velocities above 1.5 to 1.7 millisecond cannot be measured correctly. If the blood flow is faster than the Nyquist limit, the ultrasound can give false information about the blood flow, leading to an artifact called alliancing. It also has imaging depth limitation, as a lower PRF, which is the pulse repetition frequency, is needed for deeper areas, and this will lower the Nyquist limit as fewer pulses are sent out and thus increase the chance of alliancing.
Hi, my name is Shakirin and I will be explaining on power Doppler. So what is power Doppler? It basically displays the amplitude or power of Doppler signals generated by blood cell. It is related to the number of blood cells in sample volume. So it visualizes whether blood flow is present or no. So to highlight the advantages and difference between power Doppler with color Doppler is, firstly, we can take a look at the display. In power Doppler, it displays the presence and strength of blood flow. If in color Doppler we have red and blue, in power Doppler we have orange or yellow to indicate the flow intensity like turbulence or lamina. In power Doppler, we have no direction or velocity information. However, power Doppler is highly sensitive to flow, and it is also less angle dependent and has no aliasing. Power Doppler is very useful for low velocity and small vessels visualization. This is because here it measures signal amplitude which detects total energy even for weak signals. So it enhances the visualization of microvasculature. However, it also has its own limitation. Firstly, it is very sensitive to motion artifact. It has no velocity and also directional information. It has low temporal resolution and also poor differentiation of overlapping vessels. To conclude, each Doppler mode have its own use, strength, and also limitation. However, it is very important for us to know each use and suitability of the Doppler mode. This is to ensure accurate diagnosis, prevent misinterpretation, provide clinically relevant information, avoid false negative or false positive findings, and also reduce unnecessary repeat scan. So that's all from us. Goodbye!